I guess I just want to mention to people that I don't work for Advanced Ag. I was an instructor at the college when Phyllis initially came up to me and said, "What do you think about this product or this company?" And that's how it all started. And I'm like, yeah, based on what I know out there, this would be a very environmentally friendly way to go. And I would be very curious on how this stuff works. And so that got me involved in advanced ag. And so that's, I'm just going to go over, as a scientist, I'm going to give my background on how I've worked with advanced ag and what projects and where it's going. So a basic overview. I'll talk about Henderson Lake in a little bit more detail. I know Josh mentioned it. I'll talk about some study we did with Offflavor in aquaculture and where we're kind of going with some of the work too in solids digestion for bioreactor technology. So Lethbridge or Henderson Lake is Lethbridge's most popular park. It has 2.8 kilometer walking path around it. If some of you are familiar with it, you know exactly what I'm talking about. It's right in the middle of Lethbridge. Has fishing. People use it for birding, picnicking. It's surrounded by parkland, has a golf course on one end, also has Japanese gardens on the other, so it's busy. But it's part of a lake management plan. The government, I mean, the city really wanted to correct. I'll give you a little bit of background on what it was. So again, north end has parkland, golf course on the south end, Japanese gardens on the west. All of them use water from the lake for irrigation. There's a ballpark nearby too that uses the water from the lake for irrigation. The fish in the lake: northern pike, yellow perch, whitefish, white sucker, triploid grass carp, and walleye. Walleye just was netting there with some of my students, I think about 5 years ago, and came across some walleye. So the water that feeds the lake comes from irrigation. So you could get fish or small fish that migrate up through the pumps and the irrigation canals could come into the lake. Or the walleye got in there by someone introducing them. I'm not sure. I know in the past the city has used the lake for trout stocking, but that didn't work. There's about 6 kinds of aquatic vegetation. That kind of changes. I think it's not as, I don't think it's the diversity is there as it once was. And you'll see mayflies, typical water bugs, but they also have crayfish. And so if you're walking around the lake, you see birds have picked up crayfish from the shoreline and started pecking on them on the walkways just to get at them. There's also, they put in a fountain. I think it must have been about 11, 12 years ago, but they put it in about 6 feet of water. So it doesn't really provide much in the way of, it's aesthetics. It's nice to see, but it doesn't provide much in the way of, I guess, improving the water quality. So some of the problems, I think I'll introduce what the problems with Henderson Lake were. This is just a digital profile or bathymetric map of the lake. But algae blooms was a big problem, and they led to a lot of the smells. Anacystis or microcystis, the one in the top, this is what it looks like under a microscope. If you looked in the water, it turned green, or sometimes it looks like someone spilled a turquoise can of paint in the water. That's what that organism there would kind of look like. Just looks like little green specks in the water. The one below is Aphanizomenon, and it looks like little shards of grass that someone dropped in the water. Aphanizomenon is a huge one on Henderson Lake, and they used to have 1 or 2 blooms of that a year, and it just coat the rocks. And as that algae desiccates or spreads across the rocks and gets baked, it starts stinking. And again, like a lot of systems, high-end residents pay a lot of money to live around the lake. And when it starts looking and smelling like that, the city's going to hear about it. So that was one of the main problems. Both of those algae too are toxin producing species. So they can produce toxins, which could be, a dog jumping in the lake, again, could cause a problem. Aesthetics was a problem. You'd see the algae along the side, the smells, and the lake would experience periodic winter kill. And it'd be not every year, but it might be every 2 or 3 years. You'd see dead fish under the ice. It wouldn't be a complete winter kill, but again, it's a symptom of a lake that's getting very productive and oxygen's running out underneath the ice. And then you'd have aquatic weed problems. So the aquatic weeds would come right to the surface, start choking or drifting along the surface to the far end of the lake where the wind would blow any cut or fragments of vegetation, and it again would contribute to the smells. So those were the main problems in the lake. And so from a history, and I just started at 1926, but it goes way back, it used to be called Slaughterhouse Slough. So you can imagine having that picture. If that's where as a place someone said you were going to, you already in your head picture what you can expect, right? So they did have removal of goldfish, stocking of trout in 1961, expansion of the lake in 73, major renovations to the lake and then in 1999, I came to the college to work at the college in 97, and the city right away was interested in solving these problems. And I said, well, I'll take some of my students out there and collect some information for you. And they were impressed with the information we collected and said, well, can you continue to do this? And I said, sure, but they wanted to base a lake management plan on 1 week of data that I collected with my students. I said, you don't want to do that. You want to know what's going on year round. Anyway, that monitoring led for 5 years, 1999 to 2004. And from then, they wanted to do a lake management plan. So in 2005, there was an open process. We didn't get it as to be our plan. They didn't like. They went with a Stantec, a big consultancy, and basically Stantec came around after a year and said, you need to dredge it. And dredging, I remember sitting in on those talks. It was going to be $4.5 million to dredge Henderson Lake. And I'm sure they're happy they didn't go and dredge it, because when Advanced Ag started using their products, it really showed some improvements that dredging would have had an effect, but it's very, very invasive, right? You can imagine what it's going to do. Anyway, so they came back to me in 2009 and said, we want you to continue monitoring. And I've been monitoring the lake every summer since then, which is really nice to have that longitudinal data, so that you don't normally get that. So Advanced Ag came in 2010 to 2013, I believe those are the years, Josh, that I have in my records anyway, that the main functions here, the city was worried about the sludge buildup in the bottom. They didn't want to have to dredge, and they didn't want to have to pay someone to dredge or to worry about the vegetation even getting worse. So they wanted, Advanced Ag came in and said, yeah, we could do something about that. And as well with the algae blooms. So trying to tie up the nutrients in the lake. And around that time too, the city was big on creating a management plan that would work and testing different things. And you can see the image up here is something called a solar bee. And basically you have these little solar panels on floats, and underneath is kind of like a big corkscrew. And the solar panels make the corkscrew go around, and it's supposed to move the water. It helps a little bit, but it's a very restricted area that these work in. When I test around it, it has a limited area. 10 feet outside of each of the end around it is basically the limited area. So I'm not saying all of them like that, but the ones in Henderson Lake look good, but I think these were quite expensive to purchase too, but you'll see them floating out there. It is one of the things they use. From a vegetation standpoint, the city does do herbicide treatments. They go out once a week and they do spot treatments. I think Magnesite H was the chemical they used. Not sure if that's still the same one they use. And they don't really keep me in the loop on how much they're putting in or how often. But I know last year, the lake has been, I didn't see much in the way of vegetation. So we started getting dragon boats out there too. So that dragon boating and different events have really increased the efforts the city puts out to vegetation control. We've been stocking triploid grass carp as well. And that program started in 2002 as a 3-year plan. We predicted if you put 1,500 fish in there, just like if you predict how many cows you can put in a pasture to control the vegetation, same kind of thing with fish. How many fish to control the vegetation? We said 1,500. Unfortunately, the lake was experiencing partial winter kills at that time. And so some of the fish did die. We never did get to the 1,500. So vegetation was never proven to be effective the grass carp were totally effective. And even though we never got to that 1,500, the city said, yeah, we're going to use herbicides anyway. So, and then the program for triploid grass carp stopped in 2015 due to federal regulations. So there's still some fish in there, but every year they're going to have less of an impact. And that's how big they got. There was some 20-pounders in there. So I just want an overview of what the lake kind of looks like. This is the outline. Each one of these numbers is a location for sediment depth measurements. So it's around the lake, as well as some of these. I also do an analysis on the substrate to determine how much organics is in the substrate. The solar bees are the round orange locations, and the circles are lake aeration spots. So the city did start a lake aeration program and has expanded that over the years. So that's just the locations of those. So in the findings, so this is from, like I mentioned, from 2009 to 2020, since last year, I've been measuring substrate depth or sediment depth at those 13 locations. So that's why the N is 26. I do that twice a year, once in the spring and once in the fall. AWT, or Advanced Ag at the time, started in 2010 applying their product. Now that's the year too that they had to get permitting by the environment group. And so even though we wanted to do a whole year treatment, I don't think treatment started until August of that year, or July. July and August were late July, August. So it wasn't a full season of treatment. I think you got out there a few times, Josh, but that's about it. And then 2011, 2012, and 2013 were treatment years. So Josh alluded to this and showed a bit of the graph and the drop, sudden drop in solids that we're finding in the bottom, the sediment depth. And I use something called a sludge judge, or it's basically a hollow tube that you send down that you push into the substrate, and you can see how much substrate you have. So over the years, you can see that the substrate has increased after LLMO or their bacterial product stopped being applied. The city terminated it and wanted to go with aeration to see how aeration was working. Then they also did a phos lock treatment in 2016. So it's part of a larger management plan that the city had. They wanted to try out different things. Even with lake aeration, we were still getting some algae blooms, although it was dramatically reduced. And so the Phoslock was meant to coat the bottom and tie up phosphorus in the bottom sediments, or seal it in the bottom sediments. And aeration, lake aeration expanded again in 2018. So last year was a good year. Solids were down again. So maybe that expanded aeration is having an impact. But I guess I just want to show that the biggest result was when the bacteria were applied. And I don't believe in any one magic bullet. And there's a lot of factors out there. And as John mentioned earlier, like some situations don't work for a variety of reasons. Understanding each lake is really important to maximizing the impact you're going to have and coming up with a solution. Aeration, does that help the bacterial products? It does. So a variety of these factors can help. It always comes down to economics too. So if you look at, dredging, where a company wanted to come in and dredge for $4.5 million, very invasive, very environmentally destructive too. Does it do the job? For sure. You're sucking out the solids out of the bottom. But for $4.5 million, I guarantee you that's not what advanced ag product cost. I think it was somewhere around 200,000. I'm just going off memory there, Josh. I could be wrong, but significantly less and environmentally friendly. So anyway, from a scientific standpoint, something's going on there, and I can't explain it any other way. That was basically the only change we made from the previous years, is applying the bacterial product. From oxygen depth profile, I just want to explain this. So if you visualize this, it's basically going down to the bottom, or this is looking at oxygen. And if I were to measure oxygen at the surface, 1 meter, 2 meters, 3 meters, 4 meters, and 5 meters down vertically, the lake is only 5.5 meters deep. You can see that early in June, the orange, and let me see if I can pull up a laser pointer here. You can see this line, orange line at the bottom here. Early in June, this dotted line of 5 milligrams per liter is a level that you want to keep achieving. You want that 5 milligrams per liter of oxygen in the environment for fish. So once you go below that, fish are going to be compromised and they're going to move out of the area, or it's going to affect them in some way. Some fish are more susceptible to lower oxygen than others. But by July 6th here, you can see that there's no oxygen 5 meters. So the bottom half meter of the water is no oxygen. You can see that slowly follows in the 4 meter. So by July 20th, it's 4 meters down. And even at points 3 meters and down, so we're talking half the water column is almost too low in oxygen to support fish and has become anaerobic in the bottom. So these kind of situations in the oxygen profile will lead to reduced decomposition in the bottom substrates. Anaerobic decomposition is much slower than aerobic decomposition is. And so 2011, we're finding this. And again, this is a year when the Alberta Advanced Ag bacterial product was being applied. So the bacteria are taking up oxygen, but these are the conditions. Now, if I go to the next year, 2012, we see the situation's improved itself. We don't see that bottom 5 meters going to zero at all. So there's always oxygen in the bottom. That's going to help maintain the bottom substrate lower. Decomposition is going to increase, the rate of decomposition. So, and at 4 meters, 5 meters, this is a much healthier environment for fish than in 2011. So the impact of the bacteria has is not only on reducing the bottom substrate, but it's also increasing the oxygen concentration in the lake. Remember, lake aeration hasn't been applied yet. Okay, so and then if this is the 2013, again, we see oxygen levels staying well above 5 until the beginning of July, and then it's only the bottom 2 meters maybe. And again, nothing goes aerobic. It gets low, but it's not like 2011 where we had the bottom three layers of water actually anaerobic at certain times. So at no time was the bottom anaerobic here. So that's interesting to note too, just to add to the information. So basically, from bacterial treatments perspective, it reduced bottom sludge and it enhanced water quality with the oxygen depth profile for the lake. Now we get something to Offflavor, and this might seem odd to some, saying, well, Offflavor, what are they talking about? Well, in pond culture and even in recirculation aquaculture, and that's what this RAS stands for, recirculation aquaculture systems. Oftentimes you can use the best diet on fish, but you can't just take a fish out of that tank, bonk it on the head, fillet it, and fry it up, because the fish has an off flavor. It has a musty or earthy kind of flavor to it. Some people like that, but typically most North American palates don't. And it's produced by bacteria that develop in the aquaculture system. And these are natural soil bacteria, but that's basically where this study was done. It's part of a bigger study that we wanted to include advanced ag in on, because I believe that the bacteria that develop in these RAS systems can be controlled or can be influenced by providing the right bacteria to enhance the system and maybe occlude some of these bacteria creating this off flavor. And from an economic standpoint, it's really important too. So some things you must know about this is these off flavors are caused by 2 compounds. They're naturally produced compounds. They're called Geosmin or MIB, Methyl Isobornel. These are the ones that create this musty or off flavor in the fish. And they just naturally acquire it if they're in the water and the bacteria in the water. As John Wong talked about, the nitrification process is fundamental if you're reusing the same water. Just like in natural aquatic systems, in aquaria or recirculation aquaculture systems, bacteria are fundamentally important. You cannot recirculate that water unless you have bacteria in the system. And so these Nitrosomonas, Nitrobacter species that are part of advanced ag's products, and again, not the only ones there, but they're components of it, are fundamental to recirculation aquaculture systems in the biofilter. That's why it's called a biofilter. It's living. So, and then also the term depuration. Since you can't sell fish straight out of the tank and put them to market, they have to undergo something called depuration. And this depuration basically takes the fish, puts them in called clean water or water that's not in the general circulation, take them off feed, and that process can take up to 10 to 12 days for cold water fish like salmon or trout, or 5 days for something like tilapia, which is a warmer water fish. So, but there's implications of doing that. Not only is there labor involved, but there's also a dramatic reduction in weight. So you have this fish you want to put out to market, but you know by getting rid of this off flavor, there's going to be less fish there to sell. And that's a problem, right? If you're selling fish. So what we found in the study, again, this is just part of the study, looking at Geosmin, there's 4 lines here. The top 2 lines are non-depured fish. So these are fish just kept in the tank and fed 2 different diets. The dotted one has a plant-based diet. That's another part of the experiment. And the solid line is a marine-based diet. Again, not really fundamental to what we want to look at here. The bottom two lines are deperred fish or depurated fish. They are kept off feed they are on feed, but they're in its own freshwater tank, separate from the main circulation. You can see that over time, geosmin is going down. Why would they be going down if non-deperred fish, you can tell for the deperred fish that geosmin should be going down, because that's why we're actually depurating fish, keeping them isolated so they can get rid of that off flavoring. But why in these top fish is the geosmin going down? Well, let's look at the next slide to look at methyl isobornel. Same kind of thing, two lines at the top and then two lower ones. The two top lines are depurated fish. They're just kept in circulation and fed two different diets. The bottom ones are actually isolated and being fed outside of circulation. MIB, the other second off flavor component, is going down as well. Why is it going down in the fish that are in circulation? So we started treating, and I think Josh did the treatments on this, is for about 3 weeks, he used advanced ag bacterial products and treated the circulation with the bacterial products. And this drop in methyl isobornel and geosmin was the result of the bacterial treatments. So only did it for 3 weeks. So we know we have to look at this further. And like Josh said, you know, agriculture took over and inundated their time. There is research to be had. I know John Wong's done a bunch of work in aquarium systems and cell products for aquarium systems and things like that. But for recirculation aquaculture projects and industry, there is an avenue for these products. And this is just a bit of evidence to suggest that if advanced ag's bacterial products can work here, they're basically using the knowledge that we've gained from natural environments to try to mimic it here. If we can reduce off flavoring without having to remove fish and put them in separate tanks, that's a huge economic advantage for the farmer. From that study, a fish lost 11% decrease in lean muscle mass by being depurated to get the off flavor. And the only reason you depurate fish is to get rid of that off flavor. So that's a huge loss. So obviously you have a lighter fillet weight, increased muscle pH, significant changes in texture. So you have more firmness in that flesh, which is a good thing, resilience and chewiness. If you didn't have to depurate, it'd be great if you just took them off feed for a few days. Yes, they would reduce a little bit of weight by taking them off feed, but not the 11%. Like I said, it's the duration. You got to take, in some of our experiences with the trout and salmon we've had, you've got to take them at least 10 to 12 days off feed. And yeah, they just start getting quite lean and losing weight. So from the bacterial, we have to extend this study and do a study that shows the bacterial treatment for longer duration. And so what if you treated for 2 months, 3 months, 4 months, and then periodically spot treat the system? Maybe once a week do a dose, or a couple weeks a dose. What would the effect be on the off flavor? It's a huge research potential that's just waiting there to be looked at. Okay, so it did have an impact on off flavoring. Another avenue, again, in the recirculation aquaculture area, and probably some other areas that I see potential in, is at the aquaculture facility at Lethbridge College. We've worked 5 years now with these tanks that you see. and there are bioreactors. Basically what we're doing is, in a recirculation aquaculture facility, the main waste component is the fish waste. It's the first stage in the recirculation to remove the solids that is suspended in the water. So rather than going to sewer, because of a lot of our research also extends into aquaponics, basically I'm looking at it as saying, well, it's nutrients for the plants, it's just in the wrong form. It has to be in a liquid form for the plants to take it up. So let's not get rid of the solid waste. And so these bioreactors, we basically collect the solid waste from our fish and we put it into these tanks that break down that organic matter into a organic fertilizer. And each one of these can take about 15 to 20 kilos of fish waste, and each tank is around 450 liters. And we have them computer controlled to maximize the conditions for breakdown. So if you want to envision composting, we've basically worked for 5 years to develop the recipe to break down fish waste as fast and efficiently as possible, is what we've done. So that's where our research is headed, or what we've been working on. And this is just a overview of the of the control units. And then there's one opened up. So some of you might be thinking, oh, well, I'd hate to walk into that building. It probably stinks. And I keep telling some of my researchers, don't turn my fish facility into a sewage treatment plant. But honestly, this solids digestion could be a windfall for fish farmers, because now they can sell this product. If you've ever gone to Canadian Tire, 1 liter of organic liquid fish fertilizer costs $10, 1 liter. And we're converting what used to be a problem, something we have to get rid of. We can convert it 450 liters in 3 weeks at $10 a bottle. And now it's a product. Like, okay, all of a sudden you're saying, okay, that could make the economics change big time. Now, we're still trying to refine the bacterial part. So these are basically little sewage treatment plants that we're maximizing. So we have little sensors here that tell us what the conditions are, and we have actuators that actually change the conditions based on what we want. We've done this with, our research scientist has worked in chicken manure this way as well. And we've worked with different species of fish waste to see if there's a difference in the recipes. We've actually ground up whole fish and put it in as part of because a fish facility is going to have some mortalities. So rather than getting rid of those can be organic matter that can be broken down. And so basically that solids digestion, we control the conditions, maximize the breakdown. It's all aerobic. One of these went down and became anaerobic. And you bet, as soon as you walk in the front door, you will smell that one of these things went down. It stinks. But otherwise, you don't smell that this is brewing right beside the tank. So again, about 15 kilos of dry waste matter into 450 liter tank. And in 3 weeks' time, it's converted. We're now looking at using advanced ag's bacterial products to see how it influences the speed of breakdown. And we've tried one, not scientifically really, just like, let's see what happens, dumped it in. And we found that it does change the situation. Now we just need to refine it. But we see an avenue in the future to have recipes for people saying, oh, what waste do you have? Okay, here's the recipe for how it's going to control the conditions, what conditions you need to control to break down the waste product to make yourself an organic fertilizer. A lot of farmers would love this, right? Because they're often doing animals with crop production. So on site, they can make their own fertilizer. And they are when they have cattle and they spread the manure, but in this process, they can now fertigate. If you make it liquid, when you're irrigating, you can apply the fertilizer at the same time. So it's called fertigation. So again, I'm not an ag guy, but I'm a fish guy. So, but I see huge avenues in using bacteria for this part of the process as well. So I guess from here, the link from the field, from the aquatic environment to aquaculture, there's no magic bullet. The variables are too great, but we need to use nature to help understanding nature to keep aquatic systems healthy. Learn what we use from nature, apply it to enhance our agriculture production. And bacterial products, what we know about bacteria, you even see it in the stores, right? More and more products have, you know, things that improve your digestion. When we learn more about bacteria, I think we'll find out the power that they can have. And I think advanced ag is along that road and showing farmers, showing lake managers, and from an aquaculture standpoint too. I see it from the natural lake management standpoint, and now I'm seeing it in recirculation aquaculture as well. Bacteria have a huge impact on how healthy these systems are.